Hey guys, how's it going? This is Carl, and this is kind of touching base on confidence intervals with a little bit of a StatCrunch spin, and also specific to a t interval. And so, what I want to do with this is to calculate the 95% confidence interval for the positive difference in the means. There's the positive difference in the means, and what does that mean? That means it's the t interval. And what does that mean? That means that we have to actually use the t distribution for this kind of analyses. So, first off, is we need to calculate some basic things for our equations. Basic meaning the standard deviation and the mean, sample size. We need some basic calculations. And so what we're going to do with that is under StatCrunch, you click on Stat and you go to Summary Stats. And see how it divides it up. It's a little bit different than Excel. So if you go to columns and rows, so right now you can see our variables are set up as columns. Children's cereal, adult cereal. So we set up our columns, and we want to do both, obviously. We want to make sure we have those, and we want to make sure we have our n. What is n? It's our sample size. The mean, the variance, standard deviation, and standard error. All of them kind of factor in, and so we're going to actually calculate those. And just for sake of simplicity, we're going to store them in a data table also. So we compute, and we have them right there, as you can see. So the n is here, so variable 4, and if you notice, remember, in StatCrunch it's a little different. They actually get your variable over here. So moving over, you can see variable 4, variable 5. Variable 4 has a sample size of 20, whereas variable 5 has 30. The means, you can see they're drastically different. And the variance, a little bit the same. Standard deviation, a little bit. So although their averages are different, there's not much variation within those, within each column. So next step, now that we have all that we need, we have our standard deviation right here. We're going to do our confidence interval. So how do we do that? So we go back to the stat function right here, and then we're going to go to t-stats. Remember, it's a t interval, so we need the t-stats. And then we need a to-sample. And with what I usually do is with summary. So t-stat, to-sample. Why? Because there's two samples, and then with summary. So you click on that, and you'll see you'll get it right here. And you can kind of play with the visuals to kind of get what you want. Essentially, we're going to use these key variables: the mean, the standard deviation, and the variance, or mean, standard deviation, and the sample size. I'm sorry. So for the mean, for the sample 1, we'll just go ahead and pin it in there. It's 46.15, and then the standard deviation is 7.58. We'll kind of stop at 2 decimal points. 7.58, and then the sample size, as you know, it's right here, so it's 20. And then here for the sample mean of sample 2, it is 10.54. We're stopping at 2 digits. Standard deviation is 7.72. We're cutting it off at 2 decimals. And then the sample size is a little bit bigger, it's 30. And now that we have that information imputed, so instead of a hypothesis test, because this is not necessarily a hypothesis test in what I'm showing you, it's a confidence interval. 95% confidence interval. So, as I've shown you before, when it's stored in the table, it'll store it like this. But for our sake, and just so you can kind of see things a little easier, we're going to store it just in a window that pops up. So we have everything we need for this t interval. So we're going to compute, and it's going to give us our confidence interval. So let's interpret this, okay? So the mean of population 1, mean of population 2, and the difference between the means with pooled variances. So the upper limit, and this is how you read this, is 31.16, and the upper limit is 40.05, and the lower limit is 31.16, with the degrees of freedom of 48. Why is that? Because it's 50, and it's minus 1, and you're taking the differences. So this is the confidence interval for the positive difference of the population. So that is how you work it. That is how it looks in terms of a t interval and calculating it into StatCrunch. So what you would do is your sample mean, the sample difference is here, so it's 35.61 plus or minus 31.16, or actually, so it would mean that the 95% confidence interval for the positive difference in the sample means is 31.16, and 40.05. That's how you'd read it. So we hope this helps. Just let us know if you have any questions along the way. Thanks so much.